Okay, today we learn about the chapter maximum and minimum value for any real value functions. First of all, we write maxima and minima chapter name maxima and minima. These two words are plural form. The plural form of maximum is called maximum and the plural form of minimum value is called minima. First of all, we introduce these chapters. Introduction. In this chapter, we shall use the concept of derivatives to calculate the maximum and minimum value of various functions. We shall find the turning points of the graph of a function and thus find point at which the graph reaches its highest or lowest point locally. Further, we shall also find the absolute maxima and absolute minima values of functions that are necessary for the solutions of many applied problems based on maxima and minima chapters under the AOD concept. AOD means application of derivatives. Okay. First of all, we discuss about the local extremes values. Local extremum values. The local extremum values means local external points, that means local maximum value and local minimum value together called local extreme values. Okay, first of all we discuss point A, local maximum value. For this concept, we first of all we draw a graph for considerations. Suppose y-axis, which is called f of x, any functions denotes y-axis in origins, and x-axis. Suppose this way. Okay, here we take a point P, supposed to be an x-axis A, denoted by A, and we take another two neighboring points less than A and greater than A, supposed to be A minus H and A plus H. This is the curve of y is equal to f of x curve. First of all, we define this point P. P is the highest point of these regions. So this is called local maximum point. And first of all we defined f of a is a local maximum value, local maximum value of the functions f of x if there is n smaller numerical value supposed to be h and h which is greater than 0 such that conditionally f of a greater than f of x for all x in the open interval a minus h or plus h open interval between two neighboring points where x not equal to a. The point thus the point a is called a local maximum of f of x. In the figure, a is called local maximum of fx and p is a local maxima point and fa is a local maximum value of f of x. P here p is a local maximum point and ff of a, this is called f of a, okay, is called a local maximum value of the functions fx. We write is a is local maximum of f of x and p is called maximum point or local maximum point and f of a is a local maximum value. Maximum value of the functions f of x. Clear? The term local is used to sense the point P is highest point in the some regions around A. There may be other such points on the graph with this property. A functions may have either no local maximum value or no local minimum value or more than one local maximum value. Therefore, a local maximum value is also called a relative maximum value or simply maximum value. Next we discuss about the point number B, local minimum value. Okay, first of all, for this support we draw another graph in this way. X-axis y, that means f of x, origins. We take this type of graph curvically. We take same point P, graph of y is equal to f of x, and a point, neighboring points, this a minus h and a plus h. Okay, first of all we define which in this case ff of a is a local minimum value, is a local minimum value of the functions f of x if there is an h which is called numerically small value 0. We take experimentally this point h such that conditionally f of a, if f of a is less than f of original functions f of x for all value of x, all critical value also in the open interval, that is neighboring points, we take a and a plus h where x not equal to x not equal to the point A is the point in x-axis a, the point A, that means the point A is called local minima, minimum value